Hello, everybody. I'm Paul Beckwith, and I've got a special guest here, Shaun Fitzgerald. We're at the climate conference, COP29, in Baku, Azerbaijan on November 11th, the very first date of the conference. And we're going to talk about ocean CDR, ocean carbon dioxide removal methods, which is becoming more and more vital because emissions are unchecked and fossil fuel companies are getting more and more subsidies, so we're heading the wrong direction with greenhouse gases in the atmosphere increasing, not just increasing, but increasing at an accelerating rate. So Dr. Shaun Fitzgerald is the Executive Director of the Centre for Climate Repair at Cambridge. Shaun's a Fellow of the Royal Academy. Should I bow? Royal Academy of Engineering. Okay, that's different then. Okay, he works at the interface of academic research, business, government policy, and public engagement. He's worked extensively in the commercialization of new intellectual property arising from the university research, and he supported the UK government in the rewriting of policy documents for building standards. Before joining the Centre for Climate Change, Shaun was director of the Royal Institution, overseeing the program for engaging the public with science and engineering. So that's quite impressive, Shaun. So tell me about OCR and what you're up to.
Well, OCR, or in the expanded form, ocean-based carbon dioxide removal, is a whole range of different approaches that are being looked at to see whether we can actually use the ocean to do a better job at actually increasing the uptake of carbon dioxide from the atmosphere. And a long time ago, I was once asked by somebody who needed something doing, and they used the phrase, if you want something doing, ask a busy person. And I think we can all relate to why that is, because they're quite efficient and everything like that. But actually the same is true in large part also with things in nature. So one of the reasons to go and look at the ocean is that the ocean already does a huge amount for the climate in terms of absorbing a good proportion of the carbon dioxide that is emitted into the atmosphere and then taken up by the oceans. The stores are vast. There's 50 times more carbon dioxide stored in the ocean than in the atmosphere alone. And when we go and look at the various potential sinks that we've got to sequester carbon dioxide from the atmosphere, the ocean is very, very appealing just because of the large quantity that it already has there, and therefore can already be looked at to say, can it do something more for us? And then the second issue is that, are we helping the oceans or are we hurting them in their current function? And the sad truth is that, unfortunately, as a result of what's happening, we are already doing a lot of damage to the oceans, and therefore, as a minimum, I think we should be looking at what we can do to help restore the functionality of the oceans to do more in terms of carbon dioxide uptake. And that means looking after ecosystems. It means looking after those and restoring things like kelp beds that we've destroyed from the coastal zones. What can we do to try and get the oceans back into a more bountiful living environment? And then beyond that, of course, then we can see, well, are there further questions that we should be asking regarding different approaches? So that's really what drives me to it, Paul.
Yes, thank you. Now, people have thought of a lot of different techniques for removing carbon, both from the atmosphere and the oceans. And, my gut feeling is that removing it from the oceans will be a lot easier and a lot better and can be scalable. So can you comment a little bit on some of the, I know you don't like to choose one technique over another, but can you at least give us an idea as to some of the sort of front runners, if you like, or just a view of some of the different techniques that are being thought of for removing carbon? It would be very useful to our Climate Emergency Forum listeners to sort of have a better understanding of what OCR is really from a practical standpoint.
So I think the most important thing to identify with the various approaches that are being looked at regarding ocean-based carbon dioxide removal is that they have different characteristics. and some of those characteristics will appeal to certain audiences more than others. So, for example, one of those approaches is what we call ocean alkalinity enhancement. And this involves introducing some more alkaline materials, so things like olivine rock and things like that, which are really good at taking up some of the carbon or dissolved carbon dioxide in the water and turning it into a form such as a solid form. And the consequent reaction of that is then allowing some of the carbon dioxide from the atmosphere to then be taken back by the ocean to try and replace some of that which you've just taken into a different form. But the reason I quite like ocean alkalinity enhancement is recognizing the fact that they're becoming more acidic. And why they're becoming more acidic, this is as a result of some of the changes that humankind is inflicting on the climate. So it's back to the first point, which is actually how can we try and redress some of the issues that we've already inflicted on the ocean. So that's one of the characteristics, and it's one of the aspects that I do considering, although it has other challenges. So, for example, the amount of material that you physically need to handle or manhandle, or if you want to sequester, let's say, a ton of carbon dioxide out of the atmosphere into the ocean, how much alkaline material do you then need to handle? And the gearing isn't great. So it's, I'm going to say, of order, and it could be factors out, but it's of order 1 to 1. So for every ton of carbon dioxide, you've got to be thinking about moving at least a ton of rock. So one of the other approaches that we're looking at is what we call macroalgae. So one of the forms of which is giant kelp. And as a minimum there, it will be looking at the restoration of kelp beds in the coastal locations where we have destroyed it for various purposes. It might be the construction of marinas and boating and the enjoyment of our coastline, so you don't have kelp being washed up onto the beaches and rotting and causing smells. Well, actually that kelp was doing a good job in the first place in terms of carbon. So should we be restoring local coastal kelp beds? And then of course there's a further question, which is, well, if you're going to do it for the coastal regions, could you also look at including the opportunity to grow kelp in, for example, the surface waters of the deep ocean? So it's a sort of a transition of restoring what was all, undoing the damage that we've already done, and actually what more could we do to help nature. So I'm actually quite taken with the idea of looking at what we can do to grow more kelp in the surface waters of the deep ocean by providing structures, support structures onto which the kelp may grow, and then have bits fragmenting off and sinking to the deep ocean. And then the final approach that we're looking at in the group at Cambridge is looking at the role of microalgae in the form of phytoplankton, and why are there certain parts of the ocean that are more depleted in marine life than others, and is one of those reasons because we've got a depletion of minerals, critical micro minerals for life, and one of those is iron. So there has been some work done over the last 20-30 years on looking at what we call ocean iron fertilization, but to be straight, I think the evidence base is inconclusive as to whether this is a good thing or a bad thing, and actually what the scalability is. But the reason I'm quite taken with this is that if, and only if, ocean iron fertilization could be shown to be a good thing for nature, in terms of it not having unintended consequences, but actually enhancing and supporting the marine life which should be there in the first place, then it has a scalability, just the leverage. So for every ton of iron that you might decide to go and distribute somewhere in the ocean, the amount of carbon dioxide that ultimately could be sequestered isn't an order of 1-to-1 gearing. It's 3 orders of magnitude, Paul, and that's why 1 to 1,000 tons. And it gets me excited, but I've got grave concerns about it because we don't have the answers to the questions about unintended consequences yet.
Thank you. If you're going to restore macroalgae or kelp beds, I would suggest Catalina off California is a perfect place, because I lived in California for a few years and did a lot of scuba diving, and I actually dived on those kelp beds off Catalina Island, and you're in water that's 120 feet deep, and the kelp is anchored on the bottom, and it's rising up to the surface, and it's all leaves basically, because with little floatable pods, if you like, that float, and they keep the kelp upright. So it stretches, it's like a forest, 120 foot high from the bottom to the surface, massive vibrant life, all kinds of sea lions and things, and the diving leader happened to pull off his face mask or mouthpiece and had some raw anchovies just to show off as we were diving down at that depth. So I'm very familiar with the kelp. It's beautiful. And it's not there anymore. It's gone. We've lost it. Most of the kelp off California coast have been degraded by water temperature, by acidity, by other reasons, water flow, not enough nutrients. So if we can restore it, right, that maybe will take some of the fear that people have for some of these methods of removal. We're trying to restore what we had before. Now, you mentioned earlier that the United Nations, the reports and the objective of the UN is that we remove up to a quarter of present carbon emissions remove it from the atmosphere, yet they don't outline, like, I think it was 10 gigatons or something, and yet they don't suggest methods to do it yet. I mean, do they have anything about actual? I mean, are they doing any work on this, or is this like a fantasy dream of the UN, or they're just leaving it up to other people to come up with ways of removing it? So I'm not sure, but I mean that's a vast amount of carbon removal, and if emissions continue to rise, we're going to have to really scale up carbon removal even more in order to start bring the actual levels down. Actually, I wouldn't mind personally if fossil fuel companies still emitted, as long as they paid and came up with methods to remove twice as much carbon from the atmosphere as they put in, and then levels would start coming down. So, what do you think?
So, well, firstly, I mean, I don't think the United Nations feel it's their job to come up with the different methods. I mean, that is for wider society to do that, and the scientists, engineers, and everybody really is there. It's our responsibility collectively to try and devise methods by which we might be able to, let's say, sequester many gigatons per year of carbon dioxide. To my knowledge, there isn't a given approach that hand on heart can say we reckon that's got the potential, at least, of doing 10 gigatons of carbon dioxide per year, and therefore I do think it's going to be a portfolio approach, and the ocean is one of those which I think is particularly appealing because there are different approaches, and any one of those at the moment, I haven't seen numbers that exceed 10 gigatons per year. The largest one that I've heard of in terms of its potential, in terms of with the gearing ratio, is this ocean iron fertilization, but I certainly wouldn't want to go there anytime soon because it's going to take a while to answer the questions as to whether is that going to be damaging to the environment, or rather how I'd like to think that it's a really good thing for the environment, that the ocean used to be rather fuller of marine life than it is today as a result of the changes that humankind has inflicted upon it, and then as a result of ocean acidification, bleaching of coral reefs and things like that, which is to do with temperatures as well. So there have been many changes which have hurt the marine environment, and therefore we need to try and undo that. I think that land-based carbon dioxide removal approaches should not be forgotten as well, but many of those have got a challenge associated with the uncertainty associated with the degree of permanence. So even soils, which I think are have a huge potential, but we mustn't over-egg it, because they could quite easily be reversed through, for example, not maintaining the management practices which are required in order to increase the carbon content of those environments.
Yes, I mean, particularly on land, heat waves and drought can cause soils, for example, to become carbon sources, when they've been carbon sinks for an awful long time. So that's a double whammy on the greenhouse gas levels in the atmosphere. So let's change the topic just slightly. And, we've just had a U.S. election recently, and we have this particular person in charge, but we have Elon Musk involved. Now, Elon Musk is a technology guy. He's built amazing rockets, electric cars, right? We won't talk about his politics, but I think he has some inkling or understanding of climate change. if he was told, Elon, we need to remove carbon from the oceans. We have all these different techniques. Let's have 10 billion or 100 billion, right? And you'll be loved around the world if you can draw down carbon. I mean, what do you think of that sort of? I'm fantasizing right here that something like this could happen, but it might happen much quicker than getting governments to take action, right? So I don't know. Have you thought about like most people say, okay, the implications of the U.S. election and the result, that's going to really set climate back a long way. Like it's going to create chaos globally, and it's going to mean emissions are going to go way up, etc. But we don't know. We don't have crystal balls. Our crystal balls that we think we have are opaque now, right? So everything's changing, chaotic, geopolitics, all the rest. So I don't know. I mean, if Musk was to donate billions of dollars to this, I mean, who would turn it down? I guess.
So there are quite a few questions in there, Paul. And I have to say that obviously. No. I am going to comment. And so, for example, the election last week, and Trump coming in, and I have been asked by various people, what do you think that's going to mean for the climate and things like this? But I think there's a bigger question, which is what lessons can we learn about our pathway and navigating to a sustainable future with lower greenhouse gas levels? And I think fundamentally, what we really need to factor in is that there is a separation of timescales between who's paying and when it's being paid, and who benefits and when the real benefits for a changed climate are. And this is one of the insidious natures of climate change. We hear about it being a climate emergency, but we're acting too slowly. Well, if it was a real emergency in a short time scale, let's just think of the sad COVID-19. The world was turned upside down, and what happened? There was a huge effort in a very short time scale, and we're not seeing that with climate change. And I think it's in large part because of the separation of timescales, and therefore, whatever path we navigate regarding our actions for climate change, we need to carry the here and now. In other words, what will benefit people here and now, and that's where I do think. People like Elon Musk and actually thinking about, well, what are the advantages of moving now to a different way of living? What are the technologies that we have in our modern life? So why are people buying electric cars? Yes, there are financial incentives and things like that to help some people afford those. But in large part, it's not just about the climate. There are other advantages of actually moving to a completely different way of living, a different and a low carbon way of life. And that's where I get quite excited about, and I am an optimist, Paul, that I do think we're going to have to sort of change the way that we think and get really creative. And the main thing being, what can we do here and now to make things even better for current people? I'm not saying I've got the answers, but I do believe that's the mindset and the depth of thinking that we need to be applying.
Yes, I mean, the extreme weather events that are causing catastrophes around the world. I mean, just look at Spain. Yep. Just look at the fires in Canada last year and the recent fires. I used to live, when I did the scuba diving off Catalina Island in California, I lived in Thousand Oaks, and just north of Thousand Oaks is Camarillo. And Camarillo had over 200 structures just burned down, houses, just in the last few days, right? So, the area in the Appalachians, people thought it was a climate haven, high altitude, cooler, and Hurricane Helene came through and basically took out a lot of the town. And so people aren't going to be able to get insurance soon. And if you can't get insurance, you can't sell your house to somebody who takes out a mortgage. They'd have to pay in cash because mortgage companies require an insured place. So it's a whole chain reaction which we have to put a stop to. And in my view, CDR, ocean carbon dioxide removal, plus land-based CDR, plus are going to be vital, as well as, I think, SRM, solar radiation management. So can you talk a little bit about solar radiation management? I'm putting you on the spot because that's not your main area, but I'm sure you know a lot about it. So do we need both, or?
Well, I'm glad you brought up that topic, because I actually think, because of the timescales involved in the impact on the climate, that emissions reduction and the greenhouse gas removal scale up is going to be required, means that we're going to be seeing an increasing frequency and severity of severe weather events without anything else. And therefore, I do pose the question, we need as a society, I think, to be thinking very seriously about solar radiation modification. The very sad fact is that we know not enough about it right now. There's been a paucity of resources that have been invested into this by governments for research purposes alone, and therefore we have a paucity of knowledge. And I am desperate to see an increase in our knowledge base so that we can make more informed decisions about these kinds of approaches, which are varied, thankfully. So it's not just a one-trick pony. We've got a number of approaches that we could be considering applying. Some of those are more locally targeted, some of them are more regional, and some of them perhaps even globally applied. So at the University of Cambridge, where I'm director of the Centre for Climate Repair, we've got a number of different approaches that we're investigating. The first of which, in the sort of more targeted approach, is what we call ice thickening. So are there ways of thickening Arctic sea ice, for example, and indeed in the Antarctic, but especially the Arctic, to then help increase the aerial extent of that sea ice over the Arctic summer? Because if we lose, and we are losing, Arctic sea ice in the summer, that ocean is now a dark blue ocean as far as the sun's concerned and the planet's concerned, rather than being a lovely reflective white ice sheet. And therefore the amount of heat being absorbed by the planet as a result of what's going on in the Arctic is enormous, and as well as Arctic amplification and things like this. So that's ice thickening. The second one is protecting the glaciers on Greenland and indeed Antarctica by erecting structures in front of those glaciers to try and reduce the rate of ingress of deep, warm saline water encroaching on the base of those glaciers, eroding it, and then helping those glaciers slide. Can we reduce the rate at which that is happening through what we call seabed curtains? We're also looking at something called marine cloud brightening, which is to try and look at ways of making the clouds, or encouraging the clouds that form over the ocean, to be more reflective. The reason why clouds form over the ocean is because A, the meteorological conditions are favourable for clouds to be formed, and then secondly, there are sufficient aerosols, little particles, onto which vapour can condense and then form clouds. But over the oceans the air is pretty clean, the availability of aerosols is somewhat limited, and the natural aerosol in large part is therefore actually crystals of salt, NaCl, sodium chloride, that have been formed by sea spray. And therefore, can we create more sea spray with the appropriate size droplets to create cloud condensation nuclei? So we're looking at technologies at the University of Cambridge. And the last is what we call stratospheric aerosol injection, which is emulating what happens with volcanoes. And can we introduce, for example, some sulfur dioxide into the very high stratosphere, which is what big volcanic eruptions do, but doing it in a more controlled way to try and reflect some of the sun's radiation. Mount Pinatubo, it cooled the Earth by 0.5 degree centigrade for 1 to 2 years by spewing out 20 million tons of sulfur dioxide in one fell swoop. I'm not suggesting we go and hit the atmosphere as hard as that, Paul, but we need to be learning from nature as to actually what might work, and then how might we do it.
Yes, thank you. So we have done some inadvertent SRM with the International Maritime Organization restricting the amount of sulfur in shipping fuels, and we've seen warming since that's occurred. I guess, we know that the warming is uneven with latitude, so the poles are warming much, much faster than the equator, so that lowers the temperature difference to the equator, which makes the jet streams slower and wavier. Jennifer Francis is one of the leaders in this area. So, what we're talking about doing to when we talk about cooling the planet is trying to straighten the jet stream so we don't get these stuck jet stream patterns, which are causing the huge increase in severity, duration, and frequency of extreme weather events, leading, like torrential rains leading to flooding, or heat waves and droughts in other places, and so on. So Anyway, this has been a fascinating discussion. We could go on for 3 or 4 hours, I think, but we're probably both getting a bit thirsty. So, do you have any concluding remarks that you might want to make, and then you can pass the mic to me, and I'll just close out our discussions.
So, my final remark would be, the most important thing is to stop the problem getting worse. So, we mustn't take our eye off the ball, and emissions reduction. As Tony Blair once said, the 3 most important things were education. I would say we've got to make sure that we keep our eye on emissions reduction. But we know that's not going to be sufficient. So necessary but not sufficient. That brings us to greenhouse gas removal. We're going to need to drain the bathtub of some of the dirty water that we put into it. We've got to drain the atmosphere. But it's all going to take a very long time. And therefore, my final one is that we definitely need to think very seriously and building our knowledge base on solar radiation modification.
Yes, thank you very much. Years ago, I came up with the phrase three-legged bar stool, saying we need to slash emissions, we need CDR, carbon dioxide removal, and we need solar radiation management. And I feel even more strongly than I did years ago that's absolutely necessary, because we've left it too long. I mean, the way we're heading right now, we're at great risk of global food shortages, I would say, within a decade or so, if our present trajectory continues. And the only way we can halt it is to do very rapid research and small-scale deployment, and then larger-scale deployment and scaling, so that we actually bend the curve and we can actually look at greenhouse gas levels in the atmosphere and see them flattening out, stabilizing, and starting to drop. So anyway, thank you very much. And thank you to, this has been a Climate Emergency Forum presentation live from Baku, Azerbaijan. So please make sure you go to the Climate Emergency Forum YouTube site and spread it to friends, etc. Our goal is, we have one goal, and that's to educate the public on these issues that are becoming more and more vital to know something about, whatever profession or field you're coming from. So thanks again, and thank you, Shaun.